All right, ladies and gentlemen, greetings. This is the final exam review thing for honors chemistry, first semester 2018. You guys are going to get a formula sheet that's going to look exactly like this. Regular chem gets the same thing. So you'll see valence electrons around your atom. Now we talked about, we did calculating percent error in labs, but we did not talk about it at all in the review. So the formula is here. If you pay attention, you should be good to go. So what is the accepted and what is the measured? The measured is what you got in your lab. So if I measured, let's say, 3 whatevers, okay, and the accepted value is the actual measurement, and it happens to be 4, okay, so the formula is going to be 4 minus 3 divided by 3. Now, what would happen if this was a negative number? If you notice, you've got these absolute value bars there, that negative becomes a positive. So it's always going to be a positive percent error. So that equals 1 over 3 times 100, and that's going to equal about 33.33% error, rounded to 2 decimal places. Okay, so that's it. That's the calculating the percent error. Okay. And remember, we can pause this. Density equals mass divided by volume. You already know that. Here, see, right there. Electronegativities. Remember the idea behind the electronegativities? How badly does the atom want the electron from the other atom to bond to it? The higher the number, the more it wants it. So fluorine really likes electrons from another atom. We look at sodium. Nah. So you got the chart here to predict what kind of a bond exists between 2 atoms. So for example, if I look at bromium, 2.8, there's potassium with 0.8, so 2.8 minus 0.8 gives us 2. So I look on the chart here, it says greater than 1.7. 2 is greater than 1.7, so that's an ionic bond. Moving on. Mentor conversions, it's there if you need it. Okay. Temperature conversion formulas, you are responsible for Celsius to Kelvin, Kelvin to Celsius. That's just, I promised you the formula, you now have it. So now we're going to flip over to our review guide here. Okay. I'm going to go fast on this. Creation mandate for chapter 1. We looked at the creation mandate. Where would you find it? What is it God wants us to do? Where in the Bible do we find that? Maybe at the beginning? Yeah, possibly. Scientific models, what are they? Well, remember, we can't always explain things directly. So we try to develop models to help us understand what we know, okay? So things like computer models to predict hurricanes, things like putting those atomic models together. You guys remember that, to get us an idea about the shape of the molecule, right? Yeah, okay. Quantitative, qualitative data, we already talked about that. The scientific method, theory and hypothesis. So hypothesis is some kind of a possible explanation. You don't know, it's something you're going to test, whereas the theory, it's that possible explanation, but you got some data to back it up. So that might be the way to go. Okay? What's observation? Yeah, come on, you don't know that. All right. What's data? Okay. So then we talk about setting up an experiment, experimental control group, and dependent variables. So here's the idea. You're running an experiment. You're testing to see, okay, does adding acid affect the growth of plants? The hypothesis is acid is going to lower the growth of plants. So you have a control. The control group is the plant soil of the plant that you're growing. You're not adding acid to it, okay? Your experimental group is the one where you're adding the acid to it to find out if it affects the growth of the plant, okay? When you have variables, you have independent variables. Those are things that you keep the same, like the amount of soil. How many seeds did you plant? How much watering are you giving? Because if you do it both the same, those are independent variables. They should not be affecting the experiment. The dependent variable, basically, that's the variable, growth of plant, that's dependent on your experiment. That's what you're looking for, okay? Let's move on here. Chapter 2, ex nihilo, look it up in the notes. Density, we've already talked about that. Physical property, chemical properties, okay? A physical property of gold, it's colored yellow, okay? Water is colorless. Those are physical properties. Chemical properties, gold reacts with acid, it'll dissolve, okay? You can add coffee to water and it'll change the taste of the water. Chemical properties. Conductivity, ductility, malleability, luster, we already did. Okay, so physical and chemical change. Fairly simple. If I start out with substance A and I fold it in half, I end with substance A. That is a physical change because substance A is still substance A. If I have substance A and I light it on fire and watch it burn, I end up with substance B. In other words, all that carbon stuff. That's a chemical change. So physical change, you're still with the same exact stuff. Chemical change, you're dealing with something very different. Okay? All right. Mixtures, heterogeneous, homogeneous, suspensions. When you look that one up on your notes. Okay? Diatomic, monatomic, polyatomic, you guys should know that. We already talked about that. I'm just going through here. Formulas, you should know about your subscript and coefficients. Okay? You should be able to look at this and say, hey, how many hydrogen atoms do I have? Here's a clue. Distribute 4 times 2. Okay? We also talked about the idea of a ion. Any atom or a group of atoms that have a positive or a negative charge to them. Okay? That would be important. So when you look at these, this is an ion, this is not. This has no charge. So therefore it's not an ion. Entropy, we talked about that. Kelvin, Celsius, already did all that. Okay. We talked a little bit about evaporation, condensation, sublimation, freezing, and deposition. Again, those are things that you guys should know. Now, if you left your iPod on the table outside and you got water on it the next day, yeah, that's your fault. Okay, chapter 3, metric system. I didn't spend any time on that. I mean, that's just math. It's just plain math. Percent error, already mentioned it, so we're moving on. You have a percent error problem, so you can practice that. We talked about accuracy and precision. Remember, accuracy is how close to the true value you are. Precision is how close your measurements are to each other. So you can have something that is pretty precise because their measurements are close, and it's accurate because it's pretty close to the 6.295. So it's both. Whereas here, when you look at it, it's kind of scattered all over the place. The true number is also messed up. So what do? Okay? Is it precise, is it accurate, or is it both? Neither. Whoever did this did a terrible job. Okay? Okay, chapter 4, law of definite composition. So what's definite composition? What is something made up of? Okay, that's pretty much it. What is something made up of? Composition. So, composition of water is hydrogen and oxygen. Definite composition means, all right, in every oxygen molecule, every water molecule, 2 hydrogens to 1 oxygen, okay? That's a definite composition. That doesn't change wherever you are in the world, okay? So that's what we mean by the law of definite composition. This also applies to mass as well. Not just numbers, but the mass. All right, electron, proton, neutron, what are they? You guys should know this. We did talk about the Z, A and Z number. Remember, if you have an element X, okay, Z is the number of protons and neutrons. A is the number of protons. Remember, protons gives you the identity of the atom. Change the proton, you change the identity. Save the cheerleader, save the world. Okay, moving on. Niels, Bohr, Heisenberg, Pauli, Aufbau, Hansrud. You guys should be knowing this. You really should be knowing how those guys and what's going on. Like I said, just a quick thing. Hund's rule, think about the monopoly rule, okay? 4 parts of the electron's address. It's like, man, at the beginning of the one of the chapters. Electron configuration. So, here we go. What do we mean by electron configuration? This here is the electron configuration. Now, when you look at it, you've got 3 parts. This part here is your principal energy level. This part here is your sublevel or orbital, you can call it that. This is the number of electrons that are there, okay? So when we look at something like nitrogen, for example, nitrogen has 7 electrons. We look here and start looking here, 2 plus 2 plus 6, okay, that's not it. 2 plus 2 plus 3, aha. This is the correct answer, okay? Now, moving on. What does the brackets HE mean in the electron configuration? Well, it's a short answer, short way of writing out, instead of always writing out 1s1, 1s2, 2s2, 2p6, that gets to be messy. So this is talking about, it has the same electron configuration as the noble gas helium. But I'm going to go with neon. Neon's got 10. So if I want to go for sodium, there's 2 ways I can write it. It's got 11 electrons in there, so 1s2, 2s2, 2p6, 3s1. This is correct. This is the electron configuration for sodium. It's got 11 electrons. Now, with the abbreviation, 10 of those, well, that matches neon. Like this. This is the shorthand. This is how the shorthand saves you a bunch of work. Okay? So that everybody knows, oh, okay, it's got the same thing as neon. So I don't have to write all this out. So that's why the bracket with the noble gas in there. Okay? Isotopes, we spent time on that. Okay? Same number of protons, different number of neutrons, so they're going to weigh slightly differently. So when you look at carbon 12, 13, and 14, they're variations of carbon. They are, in fact, carbon. They just weigh a little bit differently, and I got to move on here. Okay. For X, you should know about wavelength and frequency, the relationship between frequency and wavelength. Okay, remember the idea behind the wavelength as you look through here, okay, the distance between the top of one wave and the next. All right, there should be a connection between frequency where how many times the wave passes a point in a given time. Okay? So long wavelength, low frequency. Short wavelength, high frequency. You guys might remember that. Okay. Units of frequency and wavelength. Think meters in wavelength. All right. And you also have, for frequency, it's the hertz, or 1/seconds. Okay. Let's moving on here. I think I'm going to stop here, and we're going to try for part 2.